Hey everyone, so today we are going to be evaluating an improper integral using L'Hopital's rule. Okay, so we have this integral here, the integral from 0 to 1 of x ln x. So why is this an improper integral? So we need to see that, so x, ln of x at 1, so it would be 1 ln 1, that would just be 0, all right? But if we do 0 ln of 0, that's not defined because ln of 0 is not defined. All right, so what we want to do here, first thing we want to do, we want to make this 0, we got to change it into terms of t, okay? So first what we want to do, we're going to make this equal to the limit as t goes to 0 from the right, okay? Because the natural log is only defined past 0. So, because it wouldn't be defined in negative numbers, only past 0. So it'd be 0 from the right, okay? So 0 from the right. So now we rewrite the integral, be t to 1, all right? And then it would be x ln x dx, okay? And now we can evaluate this. So when we look at this integral, we need to see that we have to use integration by parts because it's a variable times the natural log here. So first what we want to do, we want to identify the u, the du, the dv, and the v, okay? Okay, so now that we've identified the u, the du, the dv, and the v, we can set up the equation. All right, so it's gonna be uv minus the integral of v du. So uv, so it'd be x squared ln x all over 2 minus the integral from t to 1 of v du. So it'd be x squared all over 2x dx. And we cannot forget the limit. The limit as t goes to 0 from the right. Okay. So now what we want to do, let's pull out the constant here, all right? So I'll rewrite that real quick. Okay, so I pulled out the constant and then I simplified the x squared and the x. So now what we want to do is just evaluate this integral right here. So now it'll be, all right, so I just evaluated this simple integral right over here. And what we have left is the limit as t approaches 0 from the right of x squared ln of x over 2 minus x squared over 4 from t to 1. All right, so now what we want to do, we just plug in the 1 first. So we subtract, and then since the variable t here, which represents 0 from the right, we also have to bring the limit into this bracket here. Not this one though, because the t isn't in that first. So we have the limit as t goes to 0 from the right of t squared ln of t all over 2 minus t squared all over 4. Okay, and now we can simplify this real easily. So this ln of 1 is just 0, so it would be 0 minus quarter. All right, and minus. Okay, so now this is where L'Hopital's rule will come into play. Okay, so the limit as t approaches 0 from the right of t squared ln of t all over 2. All right, so now since this is over 2, which is a constant, we can just pull out the constant here. So we have lim as t goes to 0 from the right of t squared natural log of t minus t squared over 4. Okay, so now this right here, the limit as t approaches 0 from the right of t squared ln of t, this would be in indeterminate form, okay? Hold up. So this right here, this would just go to 0 because the limit as t approaches 0 from the right would just be 0 over 4. So that just goes to 0. So that goes to 0. But for this right here, this limit as t approaches 0 from the right of t squared ln of t, it would be 0 times the natural log of 0 from the right, which would be negative infinity. So it'd be 0 times negative infinity, which would be in indeterminate form. Okay, so since we have this in indeterminate form, we need to use L'Hopital's rule. Okay, so now to change this into an evaluatable fraction using L'Hopital's rule, it would be the natural log of t all over 1 over t squared, just like that. Okay, and now using L'Hopital's rule, we need to take the derivative of the top function and the derivative of the bottom function. So this would equal, okay, so now that we've simplified the limit using L'Hopital's rule, we can, so it's a fraction over a fraction, so we can simplify that a little more to make it a little neater. So it'd be negative a quarter minus half of t goes to 0 from the right. So it'd be t to the third all over negative 2t. Okay, and now after using L'Hopital's rule, we can now take the limit. So the limit as t approaches 0 from the right of t cubed all over negative 2t would just be 0. All right, so this whole thing would go to 0. So now our answer would just be negative a quarter, because the negative half also multiplies to 0. And there we have it. That is how we use L'Hopital's rule with an improper integral. Thanks for watching, guys.